Hello, fellow problem solvers. So today we're going to be doing an introductory geometry problem with an idea. I invite you to try this nice geometry problem out, especially if you're beginning to learn geometry. You know about and how to calculate angles. You know about the Pythagorean theorem. You know about the triangle with the angles 30, 60, 90. And maybe you even know the proofs of why the side lengths are the way they are in that triangle. And I invite you to try now this problem out for a minimum of 15 minutes, ideally 45 minutes to an hour, not more than 2 hours. If you'd like to go along with us, just draw the diagram first for the next 10 minutes. And now, here's the diagram. We have BCA is going to be 90 and CAB is 15. So we're going to have this type of diagram. Bam, a 15 here. CAB. This is 90, and this is then 75 at B. And it says if we have a foot of perpendicular D, let's prove that this is 4 times smaller than AB is. Okay. So how are we going to do this? Well, what is 15 is the question. Why is 15 important? And this, mind you, is not an easy problem. Now, why is 15 important? Well, 15, we know that if we have a triangle with angles 30, 90, and 60, that if this side is x, then this side will be 2x, and this will be x times the square root of 3. Now, you might have been told this, but do you know why this is true? Or maybe better yet, how to prove this is true? And the answer is, well, there are a lot of ways we can prove this is true. And one way is, let's say this is x. Now, what do we know in a triangle? Well, we know a couple of things. We know that if we take we know one thing. If we take the midpoint of the hypotenuse, it's the same distance from this to this and this. We know that all those things are of the same distance. And so if we connect these lines, then we know this is equal to this, and this is equal to this, which gives us that this angle right here, because this is 60, that means this is 60. But then this angle also is 60. So we have that this side is x, then this is x, because it's the midpoint of the hypotenuse. And then by the Pythagorean theorem, we have 2x squared minus x squared. The square root of that is x, the square root of 3. So that is how you prove for this triangle. And the other way to prove this is by reflecting this point with respect to this vertex here. And when I reflect it, I'll have that if this is x, then this is x as well. Now I have this is 60, and because this is a reflection, this is all 30 and 30. And so, because this is x and x, these are reflections, this whole thing is equal to this, but because we have an angle of 60, and we have this is equal to this, which means this is 2x and 2x, and that's how you prove, in fact, that the triangle with angles 30, 60, 90 has those ratios. Now with this problem, we don't have the triangle with 30, we have a triangle with 15, and we don't really have any way to directly connect CD with AB. But can we create an angle of 30? And the answer is, well, there are 2 ways for us to do that. One is by taking the midpoint of AB, this midpoint being M. Then we have that MA is MC is MB. Right? And furthermore, what do we need to prove then? We need to prove that MA, which is half of AB, MC is half of AB, so we need to prove that MC is twice the size of CD. And now what do we have when we calculate the angles? Because this is equal to this, then this is 15, which makes this angle 30. And now we have that a triangle with 30, 60, 90. And so this is twice the size of this. So we have CD is equal to half of CM, and CM is equal to half of MA, which is equal to a half of MA plus MB, which is equal to 1/4 of AB, which proves our problem. And this is literally going at this like first idea of how to prove a 30, 60, 90 triangle has these side lines. And this is why it's important also to note not just that something is true, but the proof behind how we know that it is in fact true. And the second proof uses what? Is going to use the other idea. You know, this is 90. So if I reflect B over here to point B prime, I'll get this angle is 15 as well, right? Which means I'll get the angle B prime AB is 30. Do I have a 90-degree triangle somewhere? No, I do not. So let me make one. And if I now create, I calculate all the angles, 75, 15. If I now put a foot of perpendicular from B prime here and call this point D prime, what do I know? I have this is equal to this, mind you, because of that reflection. And now these two are parallel. So by Thales' theorem or similarity, BCD is similar to B prime D prime. I have BC over B prime B is equal to, let me actually write that down, BC over B prime B is equal to CD over BD prime. And now BC over B prime B is equal to, if this is Y, this is Y, so it's Y over 2Y, which is 1 over 2. So I have that 2 times CD is equal to BD prime. What do I have for BD prime? Well, I have a triangle with angles 30, 90, 60. And so I know that BD prime times 2 is equal to AB prime. But because I've reflected this over the side AC, there's symmetry here. Maybe there's congruence if you want to call it that. So AB prime is equal to AB. And now we have AB is 2 times BD prime, which is equal to 2 times CD, which is 4CD. And this finishes up our proof. And this is a very cool introductory problem to geometry because you can't solve it right away, and you need to ask yourself, which is what you do need to ask yourself often in problems, is what does this mean? 15. Why 15? How can I use it? And it's half of 30. Now, how do I get 2 times 30? That's really the idea here. How can I get 30? I need to get 2 times 15. So how do I get 2 times 15? One way to get it is by adding this midpoint, and you get 30. And the other way to get, actually adding this midpoint right here, and getting a 30. And the other way to get it is by reflecting everything. So you get the angle 30. This finishes up our problem. Pause and watch the video over if any part I went over it too fast. This finishes up this idea. And as always, thanks for problem solving.